Okay, time now for the next chapter of award-winning innovations entitled Scale Up the Future. Well, that's a key theme of this whole event, in fact, and it's the title of the Global Transform, as I said. It's all about confronting the challenges that are posed by climate change on a global scale, not just making incremental changes, but actually making a massive impact. I want to bring Ian Monroe into the conversation to discuss this. Great to have you back with us here on the stage. Thank you for coming to see us again. Climate innovation challenges and solutions. That's the topic of your talk. And clearly here, climate change challenges are enormous. What innovations do we have? And what do we need? And what barriers need to be overcome?
Well, thanks for having me again. And it's been a fun journey being part of this, what was NetExplo now into La Maison 2050 now transition, because it really has been an amazing plethora of technological solutions. With climate change, more technological solutions are needed, but I'd say the biggest challenge to scaling up climate solutions right now really are going beyond technology to moving money and getting policies in the right place, and then really moving hearts and minds. So after teaching climate solutions, mostly at Stanford University for more than a decade, I helped write this book. It's a college textbook called Solving Climate Change. And what you can see behind is the core framework that we have for what's needed to solve climate change. And right now, the biggest missing piece is we're not setting our target at the right place. We're still talking a lot about net zero by 2050. We have government setting that target, we have companies setting that target, we have investors setting that target. But that's actually what the science said 20 years ago if we started acting then. We now need net zero by 2040 as a planet to have a prayer of holding warming below 1.5 degrees, the UN target. And really, we need to think beyond net zero to get to net climate positive, where we're actually pulling out more carbon pollution, more climate pollution out of the atmosphere than we're putting up there. So a big challenge is just getting our target at the right place. And then how do we get to net zero by 2040? And again, that's as a planet. So companies, investors, anyone with resources, certainly countries with more resources, should be moving much faster to lead the way for everyone else. So in a lot of ways, another challenge is we're overcomplicating the problem. The biggest thing that needs to happen to solve climate change is we need to end our use of fossil fuels as quickly as possible. So that's one of what we call the essential elements to solving climate change. And beyond ending fossil fuels, we also need to minimize our non-fossil pollution coming from land use change, deforestation, agriculture, et cetera. And then, as mentioned, we also need to go beyond just stopping new pollution, but actually removing from the atmosphere with carbon removal, and nature-based solutions combined with engineering solutions can be a big piece of that. So then that gets into these 8 pillars of decarbonization that we need to actually enact this climate-positive economy as quickly as possible. And there's technological pieces, there's electrifying everything we can as quickly as possible, there's decarbonizing our electricity, minimizing those non-fossil emissions, efficiency and optimization are certainly pieces of the puzzle, carbon removal just has to be a piece of the puzzle. But importantly, it's not just about the technological innovations, it's all about, as well, aligning incentives with the right policies, not just at the government level, but internally at companies, and even us as individuals, moving the money out of pollution into solutions as quickly as possible. And then last, but certainly not least, really elevating truth about not just the climate challenge, the climate problem, but the fact that the vast majority of the solutions we have, the vast majority of the solutions we need, we actually already have. It's much more about, as we have as a theme today, scaling up the future and getting to that scale up as quickly as possible.
Okay, so the climate innovations we need, are you saying basically technology, or is it more about policy, finance, and public engagement? What's the sort of the balance here?
I think technology is always great, more technological innovations, and there's a lot of inspiring technological innovations we've talked about today that certainly fit into this framework of solving climate change. But the biggest missing pieces right now are really policy innovations and financial innovations and communications innovations in terms of moving hearts and minds. And so I think out of this 8 pillars of climate action that really we all need to be implementing, whether we're doing it at a company level, as an investor, as a government, or just within our own homes, we can enact all these 8 pillars of decarbonization, but we really, more than anything, need to align incentives, mobilize money, and importantly, innovate our communications to elevate the truth about not just the necessity to act on climate, but the fact that, hey, we have all these solutions. Huge pieces of the puzzle are electrifying everything we can, and we have technologies to do that for most things. We have some new innovations like electrifying cement that's one of the award winners today. But it's really about how quickly can we push these innovations we already have, and how quickly can we take the fact that renewable energy in most parts of the world, solar and wind in particular, are just the cheapest forms of energy already. Full cost of ownership, driving an electric vehicle is just a better, cheaper driving experience. If you're in China, you can buy an EV now for $5,000. You should be able to buy an EV for 5,000 euros everywhere in Europe. So some of it is also having our incentives aligned around pushing these solutions that we already have as quickly as we can.
I want to ask you about the cost of pollution and climate change. I mean, there's a huge financial cost. There's another kind of cost as well, which is the cost of human life. How does all of this fit into our innovation equation?
We have to be valuing not just the climate pollution pieces of our current existing fossil-based systems, but also the overall human health beyond climate aspects. And there's a false narrative about climate solutions often put out there that we can't afford to do this transition yet. I would flip that on its head and say we can't afford not to. If you actually do honest, full cost accounting of our fossil fuel system, it's pretty staggering. But fossil fuels, according to research out of Harvard School of Public Health, a number of other leading medical journals, are responsible for somewhere between 8 million and 10 million deaths every single year. How we value that loss of human life, and then there's additional disease linked not primarily to climate change, but just direct air pollution from burning fossil fuels, is connected to 1 in 5 deaths. It's a staggering number, So you take that fact that just our existing system, even regardless of climate change, our existing system of burning fossil fuels has a tremendous cost related to human life, and then beyond air pollution, there's also petrochemical-linked cancers and other diseases. There's, of course, the second-order effects of propping up corrupt governments and war and other conflict related, not just to climate change, but just our overall fossil system. And when you do full cost accounting, as we did in the Solving Climate Change textbook, this is a chart out of there, and apologies, the text is a little small to read probably for those in the back, but just the quick summary is we calculated that our current fossil system costs the planet somewhere around $22 trillion every single year. And compare that with the somewhere around $4 trillion that the UN says we should be investing in energy transition, climate solution scale up. So we're spending much, much more on the existing system when you do this kind of full cost accounting than this much better climate solution system. And then on the flip side, that's the good news. There's just tremendous co-benefits. We're going to be saving literally millions of lives every year by making this transition as quickly as we can. So again, I would flip that narrative, and this is another one of the challenges, that it's too expensive to scale up climate solutions. It's too expensive not to. We're spending a tremendous price the longer we delay this transition.
Now, Ian, you did a postgrad at Oxford on AI, and ETHO Capital, who you work for as well, you run, uses AI to help determine the climate and ESG effects on, or the impacts on investments. Just tell us, what is the role for AI in tackling these issues? And do you think AI is going to help solve climate change, or is it just going to cause more pollution?
I think it may be a bit of both. And we've already talked about, and I think La Maison 2050 now has done a good job over the years of talking about not just the gee-whiz techno-optimist side of things, but also the real concerns. And of course, with AI, we are seeing it have immense potential, but also immense destructive potential. I think right now, the reality with AI and climate change is there are some neat innovations, some of which were talked about today as well. But there is also the reality that more AI right now means more energy use, which means more fossil fuel consumption. Of course, the more we push to decarbonized energy, whether it's primarily coming from nuclear power here in France, for example, or coming from renewable energy, the more that improves. We can have continuous improvements in computing systems that reduce the climate footprint of that energy as well. Just a huge piece of AI's energy right now is going to cooling data centers. So the more we make microprocessors more efficient, take away that cooling load, do that cooling more effectively. But it's actually more the second order effects that, again, we talked about a little bit earlier in the day, related to disinformation, misinformation, that also links up to climate in a big way that concerns me about AI. And a lot of it comes down to bad business models. It comes down to business models that just are using AI to optimize our attention regardless of what information we see. So it's feeding us information that we react to more, which for climate and many other issues often is misinformation, unfortunately. So flipping to the good side of things, there is tremendous potential for new innovations, for new materials, for optimizing our speed up of climate solutions we already have with some of the systems we talked about today. But something that I would love to see AI going more into, and one of the innovations today could be a piece of that solution, is basically innovating our communications, getting the right messages about climate impacts, and importantly also climate solutions, to effectively engage everyone in the world in climate action at whatever level we can, whether it's within our companies, within our governments, or just at home.
Okay. Well, thank you. I'm afraid we're out of time. We're going to have to move on, but I really appreciate what you told us. Really innovative, really insightful. We're going to have to move on to our next batch of innovations, but thank you very much indeed, Ian Monroe. Really appreciate it.
Thanks so much for having me, and a quick shout out to our Climate Positive Investing Alliance community. We have several of us in the audience really trying to accelerate the movement of money into the right places. So come find me and our other members out there, and we're excited to be a supporter of the event.
Thank you. Thank you very much indeed, Ian Monroe. Thank you. Now let's move on to our next batch of 3 innovators under this heading of Scale Up the Future. The first one's going to take us to the construction industry. It's called SUBLIME Systems. Please. Thank you.
The cement industry needed fixing because it's 8% of global CO2 emissions, and it's also a material that we really need. There's no substitute for cement. We can't do with making less of it. The world's population is growing and becoming more urban, and we need homes for these people. So if we want to achieve net zero by 2050, but we also want to build durable homes for the growing population, we need a new way of making cement that doesn't cause CO2 emissions.
So how is SUBLIME Systems actually fixing and addressing this problem?
SUBLIME Systems is addressing this problem by reinventing the way we make cement. So today cement is made in enormous fossil-fueled kilns that go to temperatures up to 1400 degrees Celsius, and that's very fossil intensive, and it also uses a mineral called limestone, which is calcium carbonate that decomposes in the kiln, releasing CO2. So the way SUBLIME is reinventing the process is by avoiding CO2 emissions. So we use electrochemistry instead of heat to break down the minerals. And because we are not using a thermal process, we can use minerals other than limestone. So almost anything that contains calcium can be broken down and digested in our process to make a reactive cement that is a drop-in replacement for the material that is presently made in kilns.
So tell us about the final product that SUBLIME Systems makes. Is it as good as and as strong as the cement we all know?
SUBLIME cement is engineered to be a drop-in replacement for Portland cement. So it has the same similar strength, durability, flow, set time, all of the things that you want in a high-performance modern cement. this is what we intend to build. So we meet a standard in the US, it's called ASTM 1157, the performance-based specification for hydraulic cement, which defines cement by all of the properties you need for it to work in today's modern construction applications.
Okay, so if we imagine that Sublime Systems cement was used right across the construction industry, that would make an enormous difference, wouldn't it, to global emissions?
That would. I mean, 8% of global CO2 emissions is a lot, and it's a sector that we think will grow in the coming years. So, you know, Sublime's mission is to have a swift and massive climate impact and to make sure that we're developing a technology that can be used in a post-carbon world. And we hope to scale up and deploy this as quickly as possible because we know that regions like China and India are going to be building a lot more greenfield cement plants in the coming years to meet their cement needs.
And what sort of a reaction and what sort of a reception are you getting, Leah, from the market?
We are getting a strong positive reception. I think people from the industry really want to decarbonize, and they're not seeing many solutions that are at scale, which is why we focus so much on scaling up our process and moving very quickly from, you know, where we were in 2020, which is a gram of material at a time, to now a pilot plant that produces up to 250 tons of cement per year. But the industry is warm because the only option right now is post-combustion carbon capture to get to net zero. And, you know, 1 ton of Portland cement results in 1 ton of CO2. And that is just a tremendous amount of carbon capture to match these giant cement kilns. And so that is a logistical problem and an added cost that the industry doesn't want to deal with.
Just tell us, where are you, in fact, with the rollout of this product in the market?
Last year, we completed our pilot plant, and so we've been running that now for 12 months. We've had 1,000 hours of uptime. We've produced many tons of cement, and we've just started to deploy it here in the Boston ecosystem. So we're working closely with Boston Sand and Gravel. We did our first construction project. It was a very cold day. We had to pump the cement over 250 feet, and it worked perfectly. So we are continuing to deploy the material, and we're also focused on scaling up our process. So 250 tons per year, we affectionately call that a cement plant for ants. A cement plant has to be about 1 million tons a year to compete on cost with today's cement plant. That's just the scale the industry is at. So our next step is to build a 30,000 ton per year plant. And so we're currently preparing the land and preparing our engineering designs to get that plant up and running as quickly as possible.
And Marie wanted to ask you something as well. Marie, go ahead.
Because I was looking at your website and detailing how the innovation works. And because usually we see electrochemical processes that are used at like relatively small scales, and I was wondering like how you were going to manage to scale up that electrochemical process at an industrial level.
Yeah, that is a very good question. So cement is the biggest man-made material by industry in the world. And so one of these cement kilns is 1 million tons a year. And to get to that scale is a big investment. And so what we are doing with this 30,000 ton per year plant is building what can be a repeating unit. So a repeating module of that 1 million ton per year plant. So 30 of these 30,000 ton per year modules would make up a full scale plant. So with this module, we can fully eliminate scale up risk. If we run this, if we prove that it works, if we prove that the economics are viable, then we can go ahead and get people to back this invention with, people have low appetite for risk when putting forward billions of dollars. And so this module that we intend to build in the coming years will fully retire that scale-up risk, and that will allow us to deploy this technology simultaneously all over the world to have that swift and massive impact on global CO2 emissions.
Okay, well, thank you very much indeed for taking the time to speak to us. Dr. Leah Ellis, the co-founder of Sublime Systems. Thank you very much indeed.
Thank you so much.
Okay, so cement accounting for about 8% of global CO2 emissions. These guys are using electrochemistry, not heat powered by fossil fuels. So Marcus, fair to say this type of innovation has the real potential to address this notion of scaling up the future and in a major way.
Absolutely, because you heard some of the figures that Dr. Leah Ellis was talking about. A ton of cement creates a ton of CO2. An average size cement facility produces 1 million tons. Anything that can drastically reduce the carbon impact of the chemical process behind making of cement. This is something I learned about. It was fascinating to see how much that process has an impact beyond the energy that is used. That has absolutely enormous potential, and I think their ambitions are on a par with the scale of the challenge.
Absolutely. So that's Sublime Systems. Remember that name when you come to vote this afternoon. Up next, we're going to be finding out about how to make buildings less wasteful. That's with an innovation that's called URBIO. Okay, up next, our penultimate innovation of our batch of 10 award-winning projects. It seeks to address the issue of making buildings less wasteful in terms of how they consume energy, notably by helping existing buildings to transition to net zero. It's called URBIO. It's a spin-off of EPFL, that is the Lausanne Polytechnique, which is a trailblazing university when it comes to clean tech. Before I bring you into the conversation, I've got a quick question for Marcus. Marcus, fair to say that part of scaling up the future, it's about maximizing efficiency, therefore cost effectiveness as well.
Exactly. If we're going to invest in an energy transition, in reducing CO2 impact, the logical thing is to put that money, put that effort into where it's going to make the biggest impact the faster. So we were just talking about the processes for building, but of course there's the huge question of making existing buildings and existing infrastructure a bit more sustainable, and I think this is what URBIO are all about.
Okay, but let's find out, because we're here with Nicolas Sommer, who is the co-founder and the CCO of URBIO. Very warm welcome to you. Could you just tell us first in your own words what URBIO is?
Yes, with pleasure. So basically we are developing a software solution in order to accelerate the decarbonization of buildings. So basically URBIO was built during a research project with European partners, and we decided then to commercialize this product. And URBIO is, I would say, divided in 3 main parts. So the first one is a data factory. It allows users, so energy providers, utilities, and consulting firms working for municipalities to access to building data and energy data, combination of open data models and user data. Then we have the digital twin. So basically it's Google Maps of energy, yeah, as you can see here. And basically similar to Google Maps, just in minutes you can access to dozens of data about buildings to do some analysis and really identify potential for PV networks and so on. And finally, last but not least, it's a generative design technology. And here this technology allows our users to generate, just in minutes, a net zero scenario for buildings in order to decarbonize them.
Okay, and AI a big part of that?
Yes, of course. So with the generative designs, so basically it sounds a little bit similar to ChatGPT, but instead of generating text or images, with our generative design technology, we can design and plan net zero plans. So it means, so basically, let's take a municipality, and you don't know exactly which measures you have to do in order to decarbonize the building stock. And with URBIO, the users, so let's say, for example, an energy provider will decide which objectives they would like to maximize. It could be like reduction of CO2, it could be minimization of cost, capex, and based on these inputs, URBIO will generate the best solution, which could be a combination of thermal networks, PV systems, heat pumps, geothermal heat pumps, and so on.
Why is it such a huge challenge to decarbonize buildings?
So the challenges is complexity. So basically what we see now is in the past it was quite straightforward to heat, for example, a building. You were connected to the gas networks and that's it. Same for electricity. And currently the complexity is increasing massively with decentralized energy systems, with some constraints about peak power, and of course about the CO2 emissions. It means that today building owners, municipalities, they have to tackle these massive challenges because 30% of emissions are coming from buildings. So it means that in order to reach the Paris Agreement, we have to reduce the CO2 emissions. But we have a lack of resources, so we heard before Bertrand Piccard explaining, and also Colver explaining that there is really a lack of resources, human resources on the market. It means that with the current resources, it's not possible to tackle these challenges. So with our solution, we can really help users to accelerate the planning of this decarbonization plans.
There's quite a big incentive, isn't there, for a building owner to decarbonize and have a more energy efficient building. I mean, the incentive you'd have thought is money. They're going to save money, aren't they?
Yes, of course. I think money is definitely one of the main trigger when someone would like to decarbonize his building. What we see also, it's the regulation. So more and more in Europe, we have some regulation on energy efficiency. It means that tomorrow, it's already the case in several countries. It's not anymore possible to sell or to rent an asset when the energy efficiency is not enough. So it's really this type of measures which motivates building owners, cities to anticipate these losses in terms of valuation of assets, but also these constraints by decarbonizing. And here we are helping them to prioritize the most, I would say, critical assets in order to invest each francs, euros in the best measures.
Okay, just tell us where you are with the rollout of URBIO and what sort of a reception you're getting from the industry as a whole.
Yeah, so it's very interesting. So a lot of traction, of course. I think we started in Switzerland now a little bit more than 2 years ago with our commercial product. And Switzerland, it's quite tricky. 4 languages, very small country, very fragmented. So it was like a good warm-up for us. And we succeeded. And then we decided, okay, let's go now to the next country. So we decided to go to Germany. Germany is also a very special market because it depends highly on gas for heating. So it means that now also with the war, there was like a lot of constraints in terms of political regulation about how municipalities have to decarbonize their buildings. So that's good for us because it accelerates also our extension in Germany. So, so we had the possibility really to surf on this wave of regulation and constraints. Same in Belgium. So we were, for example, selected. Our technology was selected to decarbonize the Brussels region, and here we can see really with our approach at very large scale and this optimization algorithm, we can help really, these energy providers and cities to decarbonize such complex problems.
Okay, and lastly, your plans to scale up URBIO?
Yes, scalability, of course. So scalability in different ways. So of course, as a product, here currently we're a team of 20 people. We plan to double the number of people in the coming years. We can rely on really impressive investors with a lot of experience in energy, in software. And on the same time also scalability in terms of market extension. So with the product much more mature, we would like to enter into more and more countries in the coming months and years.
Okay, stay with us, Nicolas. I'd like to introduce Mathurin, one of our Mars crew members, who's got a question for you. Go ahead.
Yeah, I was wondering if you are using space data to collect like CO2 emissions.
Spatial data?
Space.
Space data.
Yeah. Space.
Yeah. From spatial, you mean, or space?
From space.
Yeah. Okay. Special. Yes, we started earlier this year a project with a company which is a satellite view. They're located, I think, in UK, and basically they launched their satellite end of last year, and basically we are trying to how we can use the data that they are taking, so it's picture data, aerial picture, in order to evaluate at very large scale the efficiencies of buildings. And that's quite interesting for us because it would allow us to collect a lot of data at a very large scale, and building efficiency, it's quite difficult to do. Of course, you can go in every street and to do a picture, and but it's very costly. So with spatial, I would say, intelligence, we can definitively also scale in some ways our product and the application.
Okay, we've got a trophy for you. Perhaps we could bring it on. Okay, so very many congratulations to you for your innovation. We will, of course, give everyone the chance to vote on this innovation, URBIO, and all the others. There's a QR code, there you are, up on the screen there. Marcus, I mean, big data has a big role to play, doesn't it, when it comes to sustainability?
Oh, absolutely. There's a huge sector full of startups that are helping businesses track their impact, track sustainability, track their carbon footprint by using all sorts of data. URBIO is a very smart use of both extensive data and generative AI to come up with the best design for future or existing facilities and buildings, which of course is going to make a huge difference. And there are so many different types of data, and I know that in the last award winner that we'll be featuring very shortly, there's a whole new type of data I didn't know existed that's going to help track biodiversity and help with sustainability, so that's to look forward to.
Yes, indeed, that's to look forward to. But up next, we've got Julia back on the stage with some sustainable fashion from Denmark. It's called Gani.